Bismillah ar-Rahman ar-Rahim. I think mic is working well. Thank you very much. Good afternoon, ladies and gentlemen. Welcome to this afternoon session named Emerging Markets for Innovative Space Application. First of all, I'd like to introduce myself. My name is Tariq Al-Awadhi, and I'm Executive Director of Spectrum Affairs at Telecommunications Regulatory Authority of the United Arab Emirates. And I will be serving as your moderator for this session today. So hopefully we'll enjoy all of us together here. You will be hearing a very useful discussion on this interesting topic during the session, that is emerging markets for innovative space application. We have a 5 of industry renowned experts as our panelists today with us. And I would like to start on the rightmost. We have, actually it is my left, sorry for that, Dr. Herve Hamy, Vice President Earth Observation and Science at Thales Alenia Space. Herve Hamy started his career at Thales in 1997. He is a seasoned expert with 17 years in experience in aerospace industry and held key position in Thales. Next, we have the honor to have Sir Martin Sweeting, Group Executive Chairman and founder of Surrey Satellite Technology Limited. Sir Martin pioneered rapid response, low-cost and highly capable small satellite utilizing modern terrestrial COTS devices to change the economics of the space. Sir Martin is also director of Surrey Space Center and a distinguished professor at the University of Surrey. He recently has received the prestige Von Karman Wings Award. He is also a member of the UK Space Leadership Council. Welcome here. Then we have Mr. Marcello, Chief Executive Officer of eGeos, a joint company between the Italian Space Agency and Telespazio, playing a leading role in the Earth observation market. Mr. Marcello joined Telespazio in 1982 and later held key position in Telespazio, heading a number of projects specializing in Earth observation and distribution of satellite data. Then we have Mr. Ruben Nunez, the founder, president, and CEO Earthrise Space Incorporation, a company dedicated to provide recurring lunar payload delivery services and create technologies for commercial space transportation system that focus on landing and operating on the lunar surface and other astronomical bodies. He is also the founder of Earthrise Space Foundation, an organization that provides hands-on experience for young professionals building spacecraft. Last but not least, Mr. Salem Al-Emery. He is Assistant Director General, Emirates Institution for Science and Technology. Salem is in charge for scientific and technical affairs. His role is centered on ensuring the vision and mission of EIAST are achieved through different technical and scientific programs being run as EIAST. So welcome you here all in this session. Thank you very much for coming. And I think we start on the time also. We have very short time, 45 minutes, and we'll try our best to utilize this time by give introduction and direct questions. I would like to start with Sir Martin Sweeting, and would like to ask him to share his experience on how does a national space program provide opportunities for international collaboration, and what are the benefits? Sir Martin?
Well, thank you very much, and thank you, ladies and gentlemen, for coming after lunch. Of course, space is something now that we very much take for granted. It affects all parts of our lives. We see it in communications, in navigation and timing, commerce, monitoring the environment, monitoring our agriculture, populations, and of course during disasters. And so I think that if you look at perhaps the last 10 years, 10 to 15 years, there's been an evolution of space. Previously, in the early days of the space era, space was primarily an institutional activity. And over the last 2 decades, it has become much more widespread. The cost of access to space, both in terms of launchers and indeed with satellites taking advantage of the latest technologies, has dropped dramatically. So whereas at the dawn of the space age there were just maybe a handful of countries that could afford space, now there are something in excess of 60 countries that have built and launched their own satellites or have space programs. And this means that those countries, those nations, can participate in space firsthand and bring the benefits of space applications directly to their populations. Not only for their own national use, but there's another dimension in that space inevitably drives international collaboration. Projects sometimes are too big for one country to undertake alone, or indeed it provides opportunities for universities and research establishments within countries to pool their resources, to pool their expertise to achieve things that, again, they couldn't achieve by themselves. And there are many examples of this in the science community, in the disaster monitoring communities where, for example, the International Charter on Space and Major Disasters brings together all the countries who have space assets in Earth observation to be able to contribute data and information in response to natural or man-made disasters. And this, of course, increases the flow of information, of intellectual understanding between countries. And so it's been a really quite a dramatic increase in this inter-country collaboration, really over the last probably decade and a half. And this stimulates not only just the benefits of space to the populations, but it stimulates young people in taking an interest in science and technology. It builds up technical capacity in the countries, and later on, that technical capacity translates into new applications and new businesses. So space, if you look around the world, is really transforming the way we carry out our lives and also the way that we collaborate from one country and one nation to another.
Thank you very much, Sir Martin. Now, we'd like to see why should an emerging country procure a new satellite system when so many observation and telecom services are already available on the market? I would like to Mr. Herve Hamy to share with us his thought.
Thank you very much. It's a kind of a little bit provocative question. Indeed, we know that there are a lot of information coming from the constellations, and we Thales and Aerospace know constellations quite well through Iridium, Global Star, and so on for telecommunication. But I would say there are at least 3 reasons and maybe 1 motivation for a country to procure a new satellite. Reasons being, first, as a, let's say, legacy scheme, more security-driven, so that the country can operate the satellite with guaranteed availability, guaranteed integrity of the information, and so that let's say the country can be sure also of how to task the satellite and how to use it for its own needs. And that's, let's say, the legacy scheme. That's what we have done for example, with France, for all the governmental programs in France, where we deliver all the payloads for the submetric optical satellites. Second reason would be, let's say, more business-driven, as satellite Earth observation satellite will allow a country, service providers to develop business in the country, business in the region for maritime surveillance, for agricultural monitoring and so on. So it's more business driven so that the country has the ability to develop its own business. And a third reason would be more science driven. We see, I was personally at the launch of the Sentinel-1 satellite last week from Kourou, and it is the first satellite of the European program Copernicus for environment monitoring and climate monitoring. We see that we are, let's say, very close to very important perspectives for our countries. So some emerging countries may like to take part to this adventure, which is to monitor and to understand how the climate is changing, and to procure and to launch own, let's say, meteorological or science-driven instruments. So that would be the three main reasons. Last motivation, I guess we will get back to that, also is that procuring a new satellite is launching a space program and is a very good opportunity for developing partnerships with industry, with countries, with governments, and that's a very good motivation for a country also to procure a new satellite.
Let me continue with you now. To my understand, geopolitical perspective play an important role. Why it like that?
Yeah, that's what I've seen with the Sentinel-1 last week. We are touching with very important geopolitical issues like carbon emission, like monitoring of carbon emission and sources of pollution. For example, how to assess the Arctic area usage, the monitoring the water resources, or even getting to ability to have an early warning on natural disasters. So it's really very close to our societies, to our countries, and here we are close to these. There are actual geopolitical perspectives to Earth observation. That's what Europe has assessed with now 3 generations of satellites for meteorology, for example, all provided by Thales and Aerospace for all Meteosat satellites. It's because meteorology is completely key to our societies, and also Europe has quantified the fact that mastering and disseminating meteorology information develops business, develops economy, and it has been quantified up to 60 billion euros per annum just for Europe. So it's really at stake for political, for economical reasons. That's what we see, and so from this we see that Europe will keep on developing and is now already working on the next generation of these Sentinels for future climate monitoring. And also we have a quite interesting example of cooperation with Africa, what we call GMES for Africa, which is Global Monitoring for Environment and Security, with deployment of meteorological stations in 41 countries in Africa, allowing each country to have its own information, its own sources, and customized services for its own use.
Thank you very much. I would like to shift to Mr. Marcello and asking him why are talking about new operational application services? What have changed over the past few years? And I would like to get from you your opinion on this issue.
Yes, thank you. Good afternoon, everybody. I think we are assisting to a significant transition in our business scenario, moving from projects, specifically mapping projects, to services, specifically monitoring services. And this is happening because of 3 main factors. we now have radar sensors that can acquire data at night, day and night, and in all weather conditions. So basically guaranteeing acquisition in every condition. Second, we have today 7 operational radar satellites, 4 of which are part of the Italian Cosmos Skymet constellation that provides revisit at least 4 times a day in every part of the world, going up to 7, 8 times a day. And third, we have now a number of optical satellites that can be integrated together with the radar to provide the requested revisit, the requested acquisition capability and information content. So because of these, we are now moving from projects to services, which means basically enabling a continuous flow of information to users that are demanding sometimes even H24 services. Everybody's expecting satellites to be always up in the sky over our city, capable of acquiring an image every minute. We are not yet at that situation, but we are now facing this new capability, this new era of operational application services.
Thank you very much. I think we'll come back to you to give us later on what is those new operation application. But I have to see this now coming to our expert in lunar program. Yes, Ruben Nunez. How can lunar economy create an impact and boost economic activity?
Thank you. I feel very honored and privileged for being part of the Global Aerospace Summit and participate with other leaders of the industry in this panel. I'm also very thankful for the opportunity to work with Angelicum, a key partner in our venture to develop commercial robotic lunar landing technologies to go to the moon, and for also being one of the summit sponsors this year. Now, to answer your question, I'd like to start off by talking about taking the collaborative economy to space. Collaboration amongst entities is viable and happens on a daily basis. Ride sharing on a launch vehicle is happening or is starting to happen more frequently, where a multitude of spacecraft can be integrated with different applications, reducing the cost for countries, commercial entities, and individuals that want to get involved. Technology demonstration while utilizing platforms from service providers will also become available by integrating your payload with a spacecraft that can drop you off in your preferred orbit or even on the lunar surface. Entities can also obtain access to remote lunar analog sites, such as the Atacama Desert in Chile, Hilo, Hawaii, and one can even be set up here in Abu Dhabi. And to target a major component of the industry, ground-based communications systems, which procured $99.2 billion back in 2011, will require enhancements to deliver more data rapidly, which may also include additional ground-based communication systems.
Well, thank you very much, Ruben. Now we'd like to see from the UAE, which considered now one of the emerging market for innovative aerospace application. I'd like Salem and Marri to make us wiser on how Dubai Sat 2 and Khalifa Sat in the future are being used to benefit the UAE in this regard, and what are the future plans. So Salem.
Thank you, Tariq.
Yeah.
Well, looking at specifically at Dubai Sat 2, I mean, this was a satellite which was launched about 4 or 5 months ago, and we've already got some actual usage of this. So I've taken a note here of some requests that we've been getting, just to give you an idea of how these satellites are really benefiting the nation. So looking at disaster monitoring, we've been looking for MH370 for the past 3 weeks. Obviously, we haven't found anything, or you would have known. But we've been imaging these areas on a daily basis, and we're in interaction with the Malaysian authorities to get the latest location of where the plane might be, or the wreckage might be. Another aspect that we recently did was the Chile earthquake, which happened, I think, last week. So, we are obviously looking at disaster monitoring, as Sir Martin was saying as well. These are key applications for Earth observation satellites. Another project that we constantly work on is we look at mapping the UAE every 6 months. So obviously to have a up-to-date 1 meter resolution map of the UAE, this is something very important, very strategic for the country itself. Another interesting projects that we're working on, obviously you see all the different developments that we have in Dubai and Abu Dhabi. So just one project that we are constantly monitoring is the new canal project which is being built in Dubai. So we're monitoring this project on a monthly basis or bi-weekly basis, well, twice a month. And basically we are coordinating with the RTA and Dubai municipality, all the authorities in the Emirate that are in charge of this project, to give them this data on a timely manner. Looking at some other projects that we work on, obviously we're working on environmental aspects. We always monitor the health of the vegetation in the UAE. And we do work commercially, internationally and locally as well. Now going into Khalifasat, which is our next satellite, which will be launched in 2017. We'll do much of the same, obviously, but with a higher resolution, so that will increase our ability to obviously provide more accurate data to the stakeholders.
Thank you, Salem. Well, it was an interesting project that we are hearing, and we'll come back to you later on to get some information about your expectation for future in the UAE. However, I will go back to Sir Martin, and he mentioned something about international collaborations. Sir Martin, can you provide us an example of how an emerging nation has used a space program to develop its industrial and economic activities?
Yes, indeed. Over the last 25 years at Surrey, I come from the United Kingdom, and we have worked with, I think up to date now, 18 different countries, of which probably 15 would be classified as emerging space nations. And if we look across each of those, the programs that we have run together, and these are programs that in some cases run for over a decade, because building up the capacity in a country where the capacity does not at first exist takes time. The technical acquisition of information and knowledge is one thing, but building up the cadre of trained engineers and the scientists and project managers to then go on and maintain the program and spin it out into the commercial or industrial sector, takes probably of the order of a decade or more. There are probably two good examples actually of this out of the 18 or thereabouts. Perhaps the most, and my colleagues in Dubai, of course, will have first-hand experience of this, is in South Korea, which undertook a program back in the early 1990s to train a young team of South Korean engineers in space, who then first built, as part of a collaboration, their first 2 satellites, then went on to build their own research spacecraft, and then over the course of the next decade or so to establish their own company, in this case Satrec I, which has now since proved extremely commercially successful. Of course, having a successful space company in a country also encourages a lot of small and medium enterprises around that hub to supply them, whether it be with mechanics or components or testing or software and so forth. And I think if we were to look back at the work that we've done at Surrey and choose one which is an exemplar of this ability to establish in a non-space company a space activity and see it go all the way through to providing a national capability for their governments and a commercial activity, then I think South Korea is as I say, the exemplar. At the other end of the scale, and perhaps more recently, we've seen our work over the last, again, it's almost a decade with Nigeria, which has enabled them to establish their space agency, enabled them to have an Earth observation program, which even in the last month or 2 has been used to monitoring the development of vegetation upon which locusts depend, and by choosing exactly the right moment when the vegetation is at the right stage and the locust pupae are just beginning to hatch, you can then endeavor to control the impending locust swarms. And at the same time, then moving on and creating an agency, which I believe is now nearly 300 people, which operates not just Earth observation, but their own telecommunications satellites. And that spins out services into the community. in communications, in banking, in Earth observation, and establishing their own technical facilities builds up the local SME community that's required to supply it. Also, most importantly perhaps of all, it provides a long-term career prospects for young people wishing to enter into science, technology, engineering, and indeed in the specialist sense, space, because they can see an established program where if they devote their careers to it, they can see career progression. I think those would be the sort of two examples that I would pull out of the mixture.
Yes. Well, thank you very much for giving this example. But are there any specific application beneficial in socio-economic uplift?
Sorry, any particular?
Any particular application beneficial in socio-economic uplift?
Well, I mean, I think the applications, of course, vary very much from country to country. It depends on their national environment.
Yeah.
You know, I mentioned in Nigeria, well, you know, there are big issues in population assessment. Spacecraft can be used to try to verify the population estimates. And of course, in agriculture, desertification, the water resources, and so on. Each country has a slightly different set of problems, and so the way that space has helped those emerging space nations is different in each case.
Yes, that's true. That's true. Since we are talking about emerging economics, and here we had already mentioned about government business or services, and considering countries with emerging economics, from your perspective, Herve, what is the best satellite solution to sustain their goals?
I would say the best solution depends very much on what the country wants to do. First, it's important to precise that radar and optical observation will be very complementary and bringing very complementary information and context and availability of information. Radar will be all weather, night and day. Optical will be very, let's say, very close to what we see, so it will be very easy to interpret and to look for features and to look for information. So both will be very complementary. Then what will be the best? I would say the highest performance can be chosen by the country. That would be, for example, very much the case is in this region, where we would propose the highest available possible performance from these kind of satellites. Also for other, let's say, for example, in Latin America, some, let's say, intermediate optimum compromise trade-off can be found with, for example, some 70 centimeter resolution optical satellites, which will allow for agricultural development, which is development monitoring, which is very much at stake and which is very much a priority for these countries, for urban development, for disaster monitoring, and so on. Let's say services and use that Sir Martin mentioned. So this is very much a very good trade-off for this kind of countries. And also within the solution, I would say what is important is what kind of partnership, what kind of collaboration, and with what kind of country development is foreseen. So collaboration and country development can be of developing industry to manufacture part of the satellites or to proceed with the testing of the satellite, so that's quite a high level, let's say. It can be with service delivery, service development in a very customized way, depending on what the country wants. And there is a very good example that my colleague from eGeos could talk about from Telespadio in Gabon with the Earth Lab concept, developing services which are completely customized to the use and the needs of Gabon in its context. And in the collaboration, let's say it will be also which kind of academic education that the country wants to develop. and to which that we would accompany. And let's say this kind of collaboration, we look at it also, we consider that as a two-way innovation channel. I mean, the country, the emerging country, will look for technology maybe and knowledge coming from the from our countries, but also we are looking for challenging ideas, for new questions being asked for by new labs, and for example, we are looking for development of and prospection on nanosatellites with emerging countries, because these is where the questions are asked, and this is where we would like to work on these questions.
Okay, thank you. We'll go back now to Mr. Marcello, and you have mentioned about the new operational application services. So if you can detail some benefits of these new operational application services, especially with respect to optical and radar satellite data, as mentioned also by our colleague Herve. Please.
I will focus on three major applications or application services, as I use the term. First one is maritime surveillance. Maritime surveillance to both monitor oil pollution that could come from tanker or from oil rigs in the sea. Second area of maritime surveillance is in monitoring ship traffic, so therefore useful for border control, for illegal activities like illegal fishing or illegal smuggling. And within maritime surveillance, we have been operating for the last 6 years a routine service for the European Maritime Safety Agency. And the result, the benefit of that has been that the oil pollution due to illegal discharge in the Mediterranean area has decreased by 50%. The second operational application service is about emergency response to natural disasters like earthquakes, flooding, or even humanitarian crises. We have again a service which is operational H24, has been promoted by the European Commission after many years of developing products responding to the needs of the various member states' civil protections. Now we are in full operations. We have been in full operations the last 2 years, and we have about 5-6 activation every month. And depending on the disaster, we produce a reference map before the event within 6 hours from the activation. And we produce a damage assessment map 3 hours from the availability of the satellite data. Here we have a very clear example of integration of optical and radar, because if we have an event such as flooding, normally the sky is not clear, we have clouds, and therefore radar is a tremendous tool to perform this service. Whilst if we have some disaster due to earthquakes, optical data are the best in order to make a proper assessment of the damages to specific buildings. The third application service is land monitoring by interferometric analysis and coherence analysis. This is the powerful capability provided by radar satellites. We can measure displacements of fixed objects or buildings or other natural fixed points like rocks or similar by millimeters. So we can monitor the evolution of landslides, the evolution of subsidence, and by doing analysis before and after, we can also monitor the level of activity in a given area, especially if it is a desertic area. A clear benefit that we have achieved in the past years is about the railroad between within, let's say, the Olympic, Winter Olympic area of Sochi, where there is a railroad in between hills and the Black Sea, and due to the monitoring of the landslides risk there, we have enabled the national railroad company in Russia to build the retainer walls in the areas that were at risk for the trains and therefore for the passengers. And these are just examples of services which, I repeat, are today available 24 hours a day, 365 days a year.
Well, thank you very much, Marcello, for this detailed explanation. Mention about new applications, maritime surveillance, emergency response, land monitoring. However, well, again, say something about UAV, unmanned aircraft vehicles. And as you know, that are becoming a valuable source of data and intelligence, like for maritime surveillance. From experience, does this a threat to a satellite-based services?
My feeling is that whenever we have something new, there are two sides of the coin. There is some sort of possible competition, but I think it's more the additional information that UAV can provide that could even further reinforce the capabilities of satellite. Specifically, we have a situation like maritime surveillance where satellite can provide a very synoptic view of a large area, and therefore we can have a very useful synergy between satellite and UAVs. So the satellite is capable of detecting a ship somewhere, and then you can send a UAV at a low cost, much cheaper than an airplane or much faster than a patrol boat, to go there and with persisting observation better understand what's going on in that area. So there is, in that case, for example, there is a full complementarity between the two.
So we're not looking as a threat, we're looking complementary to the satellite services. That's very good.
Yeah.
Thank you very much. I'll go back now to Mr. Ruben and give us his experience and lunar program. Ruben, are there other emerging markets that go beyond Earth observation? Ruben?
Yes. So one of the emerging markets that not many are familiar with is the initialization of the lunar market. But first, I'd like to take a step back. I like to say that commercial innovation is driven by competition. Richard Branson yesterday posted on social media that when you spark innovation in any field, it will create and blossom into revolutionary breakthroughs in other fields. So a great example of this is the Orteig Prize, where competitors had to fly nonstop from New York to Paris back in 1919. The prize was won 8 years later by Charles Lindbergh in 1927. And I like to consider this being a major milestone in the commercial aviation industry, which giving us the capability to travel around the globe today. Another example is the Ansari X Prize, with the goal to launch a reusable manned spacecraft into space twice within a week. The prize was won by the Tier 1 project using the experimental spaceplane Spaceship One. This now has sparked the interest for people to fly in soon-to-be commercially available suborbital flights for entertainment or experimental purposes with the Lynx spacecraft from Aerospace or even Spaceship Two from Virgin Galactic. Today, another revolutionary prize is underway, the Google Lunar X Prize, which is an international competition for the first team to land a spacecraft on the moon, travel 500 meters, send HD video, several panoramic views, an email and a text message to be able to claim the total prize purse of $30 million. And Angelicum and Earthrise Space are pursuing the prize together and plan to launch their spacecraft by the end of 2015. In my opinion, this competition can be seen as a catalyst for the lunar market, which has an estimated potential of $2.4 billion in the next 8 years. Technologies to send manned and unmanned systems back to the lunar surface can be utilized to explore other astronomical bodies. In situ or on-site resource prospecting can teach us how to survive and live in harsh environments, and new capabilities may be derived for applications here on Earth. The moon is also rich with platinum-grade precious metals, which will lead to mining on the moon. And it also contains different sources of energy, such as helium-3 and water. Technologies to take advantage of helium-3 have not been created yet, but we can certainly use the water to create rocket fuel, and we can also use the lunar soil to protect astronauts from radiation and create heat shields for re-entry when coming back to Earth. These are just a few ideas that will blossom into revolutionary breakthroughs.
Well, thank you very much for this information. We just have now less than 9 minutes, but I would like to go back to the UAE and ask Salem. He gave us some interesting projects by EIAST that Salem, you have witnessed also the development and growth of the space sector in the UAE. Can you share with us your experience, and where do you see it heading in the next 10 years?
Okay, we can start by talking of the past 10 years. Obviously, I think in the past 10 years, we've seen a lot of huge growth in the UAE and the region. If we look back 10 years ago, I think we only had one satellite in orbit in the UAE. Well, two, but one operational satellite. And then if you look at now, we have, I believe we have 6 in orbit and many more on the way. So I think the UAE and the region is really on the space map now. I mean, if you look at the different projects that we have here, and that all happened really in the last 10 years. Looking at the future, I mean, I can talk about ES, but first I'll say personally what I'd like to see is that, you know, a lot of the development in the UAE is pushed by government funding. There's some obviously private funding as well, but we'd like to see some small to medium enterprises coming into the game as well. So looking at what we want to do in ES, we want to obviously develop our next satellite, KhalifahSat and KhalifahSat-2. We want to develop them in the UAE using our own engineers, and as much as possible, we want to obviously procure components or subsystems from the UAE or from the region. So we have to see, obviously, these small to medium enterprises growing along, you know, with this growth of government projects. I think another thing that I see personally happening as well in the next 10 years is a push on the education sector. So there's a big interest in universities and institutes to try and tailor specific, let's say, majors or courses towards the space industry. And this will definitely benefit all the major players in the UAE. And if we look at ES specifically, or well, the UAE and EIAST, you know, as I mentioned, there's obviously there's been commercial projects, there's been government, military, and civil projects. I think in the next 10 years we'll see a big scientific push to look at a project which can benefit science and really bring some benefit to the wider world. Thank you.
Well, thank you very much, Salem. I'll just maybe share with you some information about the UAE and the space services. And as Salem mentioned that 10 years ago, more than that, was only one satellite. I started with the satellite business in 1998. And that time we were having a filing with ITU and others, and then later it was under all Emersat file. Now later we have Thuraya, then EIAST, DubaiSat, and satellite business in the UAE is now increasing too much. And hopefully that, as mentioned by Salem, that some other sector will be involved with the satellite business. This is one of my last thoughts in this session, but personally also I feel there's too much focus on satellite and not enough on policy to increase uptake in the satellite applications. I'd like Sir Martin Sweeting to say something about this one, if you have it.
Sorry, which one was that?
On policy to increase uptake of satellite applications.
Yes.
Last thought.
Governments have a dual responsibility, if you like. Government institutions can support the private sector by helping to manage, to develop new applications where the risk to the market entry is particularly high, and where the private sector really cannot assume all of that risk. And so partnership between government and industry to pioneer some really new applications and markets is very important. The other area that goes hand in hand with that is the government's role in policy. And that's policy in terms of the regulation of frequency, spectrum, of licensing for launch. Eventually it's going to be, of course, the role of monitoring essentially space traffic control as we have more and more satellites and their applications being launched. So the governments have really key areas to play in supporting the private sector to enter new markets, but at a very light touch, not so that they direct or dampen them, but they just enable them to get over that initial risk hump, if you like, and to create the right regulatory and policy background which moves with the technology.
Yes.
And I think this is one of the things that we've observed in recent years, is technology is moving faster than the regulatory and indeed certainly the policy environment. And so if governments can get that right, and that's not easy, then it will help make the space community flourish further.
Well, thank you very much. Just on that issue, I just want to mention one thing, because I'm responsible for the spectrum management here in the UAE and also chairing the Arab group for preparation for WRC 2015. We have a lot of agenda items on satellite and especially on Earth exploration satellite services and fixed satellite services. Of course, all of them, they are asking for the frequencies. This time also, Earth exploration satellite services, they are asking for 600 megahertz and the 9 gigahertz. There are so many new technologies coming. Unfortunately, those kind of technologies sometimes is unable to be introduced or bring into the countries because the policies or regulation is not supporting. That's very important issue, and sometimes we are trying to overcome with this one. But most of the countries, they depend their policies on the outcome of WRC. So if there is nothing in the radio regulation or ITU, sometimes that will be difficult for the countries to introduce or to bring this technology. I have 2 minutes left, and I'm sorry to take much time, but I open the question for the audience if there is any questions. I have 2 gentlemen. Is there any mic here? We'll start with there and come back to you. Tfadal.
This is Abdullah Alatas. I'm aerospace engineer in Tawazun, and I was working. So I guess my question to Professor Martin regarding you mentioning the example of South Korean projects and how you guys trained some engineers to develop some satellites. So the core spirit of your project, the your proposal, how was made? I meant, was it like, did you just take all the engineers and train them, or there was like some specific project and then you trained them on these projects? That's all. Thank you.
I would try to answer that very, very briefly. The program ran, I think, for about 5 years. It comprised of several different elements. A number of the engineers, first of all, undertook academic training at a master's degree. Some of them went on to do PhDs. The majority of the team then worked as part of our team at Surrey, completely as a partnership on designing and building the first satellite, which was then launched and operated from South Korea. The second satellite that they produced utilized essentially a kit of parts which we provided from the UK, which was then assembled and integrated in South Korea. The third satellite was designed indigenous and built indigenously in South Korea. So this was quite a long program, and it comprised not just sort of watching, but hands-on partnership training, academic training, and really trying to impart the experience that we had gained over the course of those 5 or more years.
We'll take one more question, last questions. I was having here, the gentleman. It's better.
No, you need a mic.
My name is Abdurrahman Jasser. I'm from Saudi Arabia, and I'll speak from an end user. And we've been studying this satellite business for quite some time. Now, there is satellites that is a one-stop shop that will give you 2 to 3 seconds. Some of you will agree with me. It's a small satellite that will be followed that will help you in the maritime security. They will link it with the existing radars that you have. But 3 items that we are really concerned about. Are you willing to share the technology? The second is, are you willing to invest? The third one is, are you willing to manufacture in-house? Thank you.
Thank you very much. Anybody would like to answer?
I can
Please.
maybe give part of the answer, at least the first one. Are you willing to share the technology? The answer is definitely yes. When we talk about this type of services, it is fundamental that these services are performed locally by the people that know the local problems, the local situation, and not only because of the faster speed of the service, but also because you need to have a customization of these applications. So our approach is to, as it was said this morning, is definitely of collaboration and partnership, not only for the specific country where we select and we work with the partner, but also for the surrounding countries. The second question is was about, are you ready to invest? I think this is a must, because the time of space funded mainly or exclusively by governments, I think is progressively fading. It's progressively going to be over. So companies willing to be in this type of business need to be ready to invest. And there is somebody that is going to invest in satellite manufacturing, and somebody else which is going to invest in downstream systems and activities. I'm pretty much convinced that satellites are not the solution. Satellites are part of a solution, and we need always to remind ourselves that actually our business scenario is a business of the geoinformation, not of Earth observation per se. So then on the manufacturing satellites, I leave the floor to our friends of Thales Alenia Space.
It's very clear that we are willing to share. It is in our, let's say, in our model to cooperate and to develop with our customers, to share the knowledge and to build from that for the next programs, and to build from that to accompany our customers. So there is no doubt about that, and that is very much, let's say, our policy, if case need be. I would add just one thing, that beyond the satellite, we also need to be to consider the infrastructure, which is the IT infrastructure, which is necessary to disseminate and to use the information, providing also all the security, the cyber security, all the, let's say, the IT level of technology, be it cloud, be it big data, be it cyber, to be able to use this data in a secure manner and in a usable manner, and to disseminate the products to all the users. So that is also, let's say, close to the satellite, not the satellite itself. We need to consider that also in the equation.
Thank you very much. I wish that we have more time so that we can hear more interesting information. I really enjoyed to hear to all from our experts here. Thank you very much to all of you. Thank you very much also for your participating and for listening to those information. I'd like to thank all of you, and thank also to the organizer.